Good morning, everyone. This is lecture number 5, and we are moving on speed and velocity. In the last class, if you remember, we had done some problems on average speed. We had seen what is speed, and we had done some problem on average speed. Do we remember this? A particle covers one part of the distance with this much speed, other part of the distance with this much speed. What is the average speed? Do we remember those questions? Yes or no? Okay, in this part we will move on and we will see the types of velocity. So the heading for this class to begin with is velocity. Please write the heading velocity. Please write the heading velocity. Now velocity is represented by the letter V with a vector because it is a vector. So what are the things that you must remember about velocity? As soon as you hear the word velocity, it is the rate of change of change of position vector. So that is the correct
Sir, am I
definition.
audible?
Yes, sir.
Hello?
Yes, sir. You're audible.
Hello?
You're audible, sir, but you can't hear me. Speaker is not working. Rate of change of position vector in your question or books, they might say displacement. Rate of change of position or displacement with time. I will just write a message. Okay, so velocity is the rate of change of position vector. Sometimes the question might say displacement. Displacement is not correct. The correct thing is it is the rate of change of position vector with time. Do we understand this? Yes or no?
Hello?
Yes, sir,
Hello?
you're audible. Am I audible? Okay, it is the rate of change of position vector with time. Do we understand this? Great. What type of quantity is velocity? Velocity is a vector quantity. So it consists of two parts. It consists of a magnitude part and it consists of a direction part. Do we understand this? Magnitude and direction, two parts. The SI unit is meter per second and the dimension is LT minus 1. Do we understand this? Everyone? This is velocity for you.
Sir, not audible, sir.
Do we understand this, everyone? Yes or no? Okay. Now, when I talk about velocity, you talk about what are the different types of velocity. When you talk about velocity, you can also talk about the various types of velocities that you are going to encounter. Do we understand this? The
Hello?
various type of velocity. The various types of
Hello?
velocities are
Hello?
the various types of velocities are Just give me a minute.
Hello.
Okay, do we have we noted this down? Yes or no? Then the next thing is that we talk about the types of velocity. Types of velocity. Types of velocity. Now, can you tell me what are the types of velocity? What is the first type of velocity?
Uniform velocity, sir.
Very good, my dear friends. Very good. The first type of velocity is uniform velocity. The first type of velocity is uniform velocity. Okay, do we see this now? The screen is visible now, beta? Okay. So, we were discussing the types of velocity, and the first type of velocity that we got to discuss is uniform velocity. Now, what is the other terms that we can use for uniform velocity? We can use constant velocity, or we can say that the velocity remains same. Do we understand this? So whenever we talk about uniform velocity, the first thing that should come to your mind is velocity remains same.
Sir, in
Velo-
Chindal Center now, okay, sir? Voice is coming.
velocity remains same or constant with time. Velocity remains same or constant with time. That means the velocity does not change. When I say that the velocity remains same, it remains same in magnitude, and it also remains same in direction. Do we all understand this? Velocity remaining same, it remains same. Well done. In magnitude, it remains same in direction. Now, velocity remaining same in direction, that means the direction of motion cannot change. The direction of motion cannot change. You can write one thing here also. Okay. The direction of motion cannot change. So you can write this. The direction of motion remains same. Direction of motion remains same. That means this motion becomes a SL. What do you understand by SL? What do you understand by SL? SL means that the motion remains
Straight line.
straight line, or it is strictly motion in one dimension. You can also understand this uniform velocity in this way. The particle is moving with uniform speed in the same direction. Do we understand this? The particle moves with uniform speed in the same direction, or it covers equal displacements in equal intervals of time. Is it clear to everyone what we mean by uniform velocity? I have tried to explain the same thing in different ways. Velocity remains same. It remains same in magnitude. It remains same in direction. Direction of motion does not change. Particle moves in a straight line. It is moving with uniform speed in the same direction, or is it covering? It is covering equal displacement in equal intervals of time. I'll give you 1 minute to note them down. Have you noted them down, bacha? If you have noted them down, then you move on to the second type of velocity. And what is the second type of velocity that we'll encounter? The first is uniform velocity. What will be the second type or second kind? Yes,
Non-uniform velocity.
it has to be non-uniform velocity. It has to be non-uniform velocity. It has to be non-uniform velocity. What is the other term for non-uniform velocity, my dear friends, that we can use for non-uniform velocity? We can call it variable velocity. Do we understand this? A particle moving with variable velocity. That means velocity.
Velocity changes.
Yes, velocity changes with time. Sometimes it is this, sometimes it is this. Velocity changes with time. Velocity changing with time. It can change in magnitude, it can change in direction, or it can change in both. If it changes in magnitude, it is non-uniform velocity. It is changing in direction, it is non-uniform velocity. It is changing in both, it is also non-uniform velocity. Do we understand this? Or we can say it travels unequal displacement in equal intervals of time. That is what I mean by non-uniform velocity. Is it clear to everyone? Yes or no? Okay, that was the second type of velocity. What would be the next type of velocity that we might encounter?
Average velocity.
Well done. It seems like you are prepared. Very good. I am very impressed. Average velocity. Average velocity. Now, how will I write this average velocity on similar lines? V, V with a vector inside this box, dabba. This becomes your average velocity. Now, can you tell me what is average velocity? Average velocity is the total displacement divided by total time. Average velocity is total displacement by total time. So if you have to calculate average velocity, it will be delta r vector, which is total displacement divided by total time. You can also write it as r2 final position minus r1 initial position divided by total time. Do we understand this? This is how we understand average velocity. Now again, average velocity is a vector. What is the direction of average velocity? Direction of average velocity is same as, you can see here beta in this equation, average velocity is total displacement. The only two vectors here are, this is one vector and this is the other vector, because time is a scalar. Therefore, you are expressing one vector in terms of the other vector. That means the direction of this vector would be same as what? The direction of average velocity will be same as what? It will be same as the direction of displacement vector. Do we understand this? The direction of average velocity will be same as your displacement vector. This is your third type of velocity, which is average velocity. What would be the fourth type? Oh, before moving on to the fourth type, you must remember that whenever we talk about this symbol average, average velocity or or average acceleration, anything, whenever we say average, it is always calculated. Average velocity is always calculated over an interval of time, from one time to the other time. So whenever you calculate average velocity, it is always calculated over an interval of time between 2 points or between two times. Do we understand this? Average of anything is always calculated over two instants or 2 points in space or 2 points in time. So this is a very important factor. Can I have raised hands from everyone that we all understand this? Now, average velocity,
Sir,
well done. Average velocity is calculated
hello.
over an interval of time.
Hello.
Yes, beta? Everything okay? Okay, average velocity is calculated over an interval of time, then there must be something which can be calculated at any instant of time. What is the fourth type of velocity?
Instantaneous velocity.
Instantaneous velocity. Instantaneous velocity. We represent this by v vector, and as soon as we represent this by v vector, we must understand that whenever we are using the term velocity in general, whenever we are using the term velocity in general, whenever we are using the term velocity in general, whenever we are using the term velocity in general, I'm asking you, what is your velocity? Which velocity are you going to tell me? Whenever we are using the term velocity, which velocity are we talking about? We are talking about instantaneous velocity. It is same as whenever I ask you what is your speed, you tell me your instantaneous speed. Do we understand this? So this is the velocity of the body at any instant or at any point. Do we understand this? This is the velocity of the body at any instant. Clear? Now to find this velocity at any instant or instantaneous velocity, what would you do? You will take the derivative of r with respect to t. Do you know how to differentiate? Yes or no? Is it a yes or is it a no? I did not see it. Yes or no? It was taken in the class before? Basic maths? No. Some people are saying yes, some people are saying no. So I will take a yes or I should take a no? What is the majority saying? Yes or no? No. Majority says no. Okay, not a problem. So this is the derivative of r with respect to t. So I can also call it as, this is what is called as rate of change of PV. Do you understand the meaning of PV? PV, not PV Sindhu, right? She's from Hyderabad, I know that. But this PV is not PV Sindhu. What is this PV? I can't hear you, bacha. What is this PV?
Position vectors.
Position vector. Position vector with time. Do we understand this? Yes or no? Now, there is one more way of understanding this instantaneous velocity. If I ask you what is your instantaneous velocity, how are you going to tell me your instantaneous velocity? Suppose you are sitting in a bus or a car or a bike. If I ask you, Bacha, what is your instantaneous velocity? How will you tell me? You will tell me how. So you will look at the speedometer. Do you remember that speedometer? That goal thing? That round thing? Speedometer? Have you seen it? No? On a bike, on a car, speedometer that tells you 30, 40, 35, 45, 100, 80. Yes or no? You have seen this? That speedometer tells us instantaneous speed. Do we remember this? Speedometer tells us instantaneous speed. So you tell me your instantaneous speed and then you add direction to that instantaneous speed. That becomes your instantaneous velocity. So instantaneous velocity is instantaneous speed, instantaneous speed with direction. Now something has happened from my end. God save us. These things, sometimes they are not in your hands. Yeah. Anyways, it comes. So instantaneous speed with direction becomes your instantaneous velocity. Do we understand this? Do we understand this? Or you can say magnitude of instantaneous velocity is instantaneous speed. Now, many a time, I think in 11th standard, whenever you would have talked about velocity, the first thing that you would have heard about velocity is speed with direction. Well, that thing is only valid for instantaneous velocity. Instantaneous velocity is instantaneous speed with direction. Do we understand this? So whenever we have said velocity is speed with direction, we have referred to this velocity which is known as instantaneous velocity. Do we understand this? Yes or no? No, yes. So I can use this symbol. This symbol means magnitude of instantaneous velocity, and I can simply call it as S, which is a symbol that I've used for instantaneous speed. Do we understand this? This magnitude of instantaneous velocity is also written as V, and therefore in most of the books, this symbol V is used for speed. But I am not going to use V for speed, because when I write your equations of motion, I am going to use V, and that time that V is not going to mean speed. That time that V is going to still mean velocity. I don't want you to confuse between speed and velocity, and therefore I'm using different names and different symbols for it. V stands for velocity, S stands for speed, S does not stand for displacement, delta R stands for displacement. Do we understand this? Yes or no? No, yes. Okay. Now, can I start with some questions? I'll give you 2 minutes to go through this entire thing from your notes, from the sheet, from the whiteboard, and then I will give you questions based on instantaneous velocity. 2 minutes, go through this, and I will get you the questions. If you have any doubts in the meantime, please feel free to ask them. Have you gone through it? Yes or no? Shall I begin my question? Yes? No? Yes? The question is very simple and question is right now on your screen. Now remember, the name of the chapter is motion in 1D, but is this motion in 1D that I have drawn? Is it motion in 1D or is it motion in 2D? 1 or 2? 1 or 2? Is it motion in a straight line, motion in 1D that you see here? Or is it motion in 2D? Yes. This question does not involve physics. Is it motion in a straight line? Motion in a straight line is motion in 1D, or is it motion in 2D? Yes. Looking at the board will not give you the get me the answer, beta. Is it motion in 1D that I have drawn? A particle moves from A to B. Is it motion in 1D or is it motion in 2D? Anyone? Please tell me. 1D? Is it looking to you like motion in a straight line?
1D, sir.
This question that I have drawn, particle moves from A to B. It looks like a circle. I have drawn a circle of radius r. The particle moves from from A to B. Is it motion in 1 dimension? It is motion in 2 dimension. It is not moving in a straight line. Okay, a particle moves from A to B. The radius of the circle is 5. The first question is, you have to tell me what is the distance traveled by the particle. What is the distance traveled by the particle? Can anyone tell me what is the distance traveled? How do you find out the distance traveled? You will find out the length of this yellow line. Yes or no? Can you tell me how much is the length of this? Do you know the circumference of a circle? How much is that? Circumference of a circle, beta? Circumference of a circle, this entire circle The circumference of this entire circle is how much? 2 into pi into r, yes or no? R is 5 meters, 5. So this will be 2 pi multiplied by 5. That will be equal to 10 pi. Do we understand this? Yes or no? The circumference of this circle is 10 pi. Yes or no? We understand this? So how much will be this part? How much will be this part? The yellow part. Now the yellow part has gone. So let me make this pink. How much is this part from A to B? That will be entire length, which is 10 pi divided by 4. This is 1/4 of a circle. Yes or no? Yes or no? So this will be equal to 10 pi by 4. If I solve it, I will get 5 pi by 2. So the distance traveled by this particle when it moves from A to B is 5 pi by 2. Do we understand this? This is the distance traveled by the particle. Yes or no? Let us now talk about the displacement of the particle. How much is the displacement of the particle? It has got two things. One is the magnitude. We will write the magnitude here. The other thing is the direction. What is the direction of displacement? To find out the direction of displacement, what do? You join a straight line from A to B, and the direction of displacement is like this. Yes or no? This is the displacement. So direction of displacement is from A to B. Do we understand this, bacha? The direction of the displacement from A to B. We understand this? Now let us talk about the magnitude of this displacement. Can anyone tell me what is the magnitude of displacement? Magnitude of displacement is the length of this line. Do we understand this? How will you get the length of this line? How will you get the length of this line? If you look closely, you will see a right angle triangle. This is O, this is A, and this is B. This is 5 meter, this is 5 meter. Can you tell me how much is this? You have seen a right angle triangle, yes or no? You know Pythagoras theorem, yes or no? Yes or no? So this will be hypotenuse square is perpendicular square plus base square ka root. So this will be root of 5 square plus 5 square. So this will become 5 times root 2. Yes or no? So that will be the value of the magnitude of displacement, 5 root 2. Am I clear with this? Yes or no? This is 5 perpendicular, this is 5 base perpendicular square plus base square, and I take the under root, I will get the hypotenuse square. Yes or no? You understand this? Okay, so I've got the distance and I've got the displacement. Now I can calculate average speed. Average speed is total distance divided by total time. Total distance is 5 pi by 2. Total time, you can see here, total time is 2 seconds. So 5 pi by 2 divided by 2. So my average speed will be 5 pi by 4 meter per second. Total distance divided by total time. Are you following me? Yes or no? This is a yes, this is a no. Are you following me? Say yes or no. Do you understand this up till here? Yes or no? Everyone? Okay. Please note it down. Then I find the average speed. How do I find the average speed? Average speed we have found out. I find the average velocity, total displacement divided by total time. Total displacement is 5 root 2. We have already calculated it. Hypotenuse divided by total time is 2. So I divide them and I will get 5 by root 2. That is the answer for average velocity. Average velocity is total displacement divided by total time. Average speed is total distance divided by total time. Do we understand this? Yes or no? I'll give you 2 minutes to note this down, please. Please note it down. If you have any doubts, please ask. Yes, my dear friends, you have noted this down? Shall we move on to the next question? And here comes a simple question for you. A particle moves from A to B, then from B to C, then from C to D. They are part of a square, three sides of a square. Time that it takes is 10 seconds. It takes 10 seconds, that is the total time from A to B, B to C, and C to D. There are four things that are being asked. The first thing is L. Do you know what do you mean by L? The first thing I have written is L. What do you mean by L? What do you mean by L that I have written? Please tell me. I'm waiting for your answer. If you don't understand the question, how would you solve it? What do you mean by L? I've asked you four things. Find L. What do you mean by L? Anyone? No one knows what is L? Please tell me. What is L, beta? L? No idea? Do you know it or not? Please say yes or no at least. That we don't know, sir, what is L. You don't know what is L?
Ah,
L is the distance, beta. L is the length of the path, which is your distance traveled. Okay, well done. What about this delta R? What is this?
Displacement.
Okay, well done. Displacement. What about that S in a dabba? What is this? What is this?
Speeds.
Average speed. Okay. What is this?
Average velocity.
Okay. So I hope you understand the question. You have to find out the distance, displacement, average speed, and average velocity. I'll give you 2 minutes to solve this. So I think you have answers. Tell me, what are the answers? What is L? The distance traveled by the particle. It goes from A to B, B to C, C to D. What is the distance traveled? Yes? Distance traveled, L. This is 5 meters. This is 5 meters. And this is 5 meters. How much is the distance traveled, beta?
15 meters.
Very good. Very smart. 15 meters. Well done. Let us talk about the second thing. The second thing is the displacement. Can anyone tell me what is the displacement? Delta R. And I will color it with pink. Can you tell me what is the displacement?
5 meters.
Yes, it is from A to D. You just have to tell me the length of this line. Very smart. That is 5 meters from A to D. Now, can anyone tell me what is the average speed? Average speed. Yes. You know total distance.
3 by 2 meter per second.
Well done. Total distance is 15. Total time is 10. So it is 15 divided by 10. It is 3 by 2 meter per second. Very good. What about dabba V, average velocity?
1 by 2.
Good. Total displacement is 5. Total time is 10. So it is 1 by 2 meter per second. I hope you have understood the difference between distance, displacement, average speed, and average velocity. Yes or no? Have you understood this? Anyone has any doubt? Please tell me. Well, then that brings us to an end of this class. In this class, we have seen the meaning of velocity. We have seen what are the different types of velocity. We have seen what is average velocity. We have seen the difference between average velocity and instantaneous velocity, average velocity and average speed, instantaneous velocity and instantaneous speed. We will meet in the next class. Take care and may God bless you all. If you have any doubts, please ask me.